Hi all, thanks for taking a look at the Kickstarter. This section is about latency. Now this is a massive subject and something that's really important to people. But before I get on to the latency, I wanted to just go over again the aims of this Kickstarter. The idea of this Kickstarter is to build a platform on which to build different types of monitors for different applications. Most of the funding is to go into tooling up so we can make this chassis. You will see other videos in this Kickstarter describing the chassis, so I won't go into depth here. But important to note is that having the chassis in this platform means that you can put different panels in it, different controllers in it. I actually changed the structure of this Kickstarter about 6 months ago after getting some feedback from someone who I greatly respect in the retro community who saw the monitor, had some feedback, not all good, but it made me clear that it's not really, I know it sounds silly, it's not really about the panel, it's about building this system so that we can put panels into it. And I found a nice panel, which is a nice industrial panel, which has got great quality, and I've been taking it to 2 or 3 shows, and probably 2,000 or 3,000 people have seen it, and it was very popular with the quality of the whole project and the display. And so far I've got nearly 700 people on the waiting list, so hopefully I'm doing something right. But one big thing about this was, and I suppose this is the key change, now I'm communicating this properly, whereas before my plan was we'll launch it with a panel and then I'll do some others down the road, but it wasn't clear enough for people, and some different people have different needs for a panel. So the Kickstarter basically will fund the chassis, and then later into the project, but basically I'm going to Asia, and I'm going to go and have a look at loads of panels and see if I can track down some really good panels, some less expensive panels, and really go to town, because the problem I've had is I've been buying lots of panels from suppliers, and of course I must have bought nearly 10 panels, and you know, it's a really expensive way of experimenting. It's actually better off to wait until the funds are there, then I can fly out and I can go and visit all the panel makers, tell them what I want, and really go to town on this and come back with hopefully perfect options. Now the other side of this is it means that potentially, assuming you can get firmware and the firmware is okay, you could put your own panels in this, and panel and controller, and you can really customize this chassis to do what you want. Right, now let's go back to latency. I want that to be clear so people understand that this panel is my choice of panel, that will be the default option, but it's not necessarily the one that you will want to buy. You will have other options. There will be a lower cost than this panel because it's an industrial panel, it's pretty high quality, and they're meant to last. So in an ideal world I want to see if I can get something that's good, still good, but cheaper for people. And then basically I just want to go out and find putting it bluntly, a balls to the wall one that will really make the gamers happy with it. So right, let's go down. So what I wanted to do to in this video really was absolutely nail this, so you know what you're getting, and that's the absolutely crucial thing. So what I'm going to do is I'm going to go into a different view now. This is the machine I set it all up on. So if I explain what's going on here. So basically, how do you measure latency? Now, I happen to have I've actually got one of these, but this is the only latency tester I could actually get. So this is HDMI, it's a well-known one, and I'm going to put the figures up in a minute so you can see. So this, you know, literally, this is what it is. But then how do you test the latency for everything else? So what I came to the conclusion was this, that I'll use an Amiga because I'm an Amiga fan. Why not use an Amiga? It's got 2 video outputs. Now this is the crucial thing. So what you can see here is I've got my PVM. Now the reason it's in black and white is because it's an NTSC at 60 frames. Now I think there's something weird going on with the signals, but it is coming out, it's 60 FPS. But it is rolling a little bit because of the video recording and so on. But the main, this is the 19-inch version, and that is the Amiga's display is running in NTSC. It does confuse the panel. Hang on, I just want to be completely open here. So hopefully you can read at the bottom, it says 1280 960 by 60 Hertz. Now the reason for this, it seems to perform better. It basically doubles the size, and it seems to perform better in this mode. That's what that's running at. If I just wakey. Now I've got the brightness down on this, and it's just so you can see it, but I'm going to be doing it differently in a second, and you're going to see the captures. But so basically what I've got here is I've got an Amiga running an NTSC display. So it's, the key thing here is 60 frames a second. I've set it for that so we can, I think that's the best. I just decided, I tried to do it 120 so I can actually see exactly, but couldn't get my cameras, any of my devices to do 120 reliably. So I'm setting it at 60. But what we're doing is this. Right, I'm going to run. I'm using D-Paint. Now, D-Paint's really good for animation. And you can see here, I've got an animation 60 FPS. Okay? Now, I'm a simple kind of guy, so it seemed to me, well, I'll tell you what, obviously, this is a CRT, it's also a PVM, Sony PVM, so they're really good. That's going to be knocking on at 60, let's turn it up a little bit more, there we go. That's 60 FPS, that's 60 FPS, both NTSC. And I'm going to run it, so all I do is that. So what you're going to see is the recording, and then I'll step through and you can see how far behind this one that one is. I think that's, now it's not completely scientific. I don't have a tester to get any more accurate than that, but what it will do is it will tell you how many frames I'm behind. So remember, it's the really crucial thing is 60 FPS. Okay, so let's get into that. Okay, so what you can see on the screen here, this is the accurate figure for my lag testing. Now, I must admit I did post one of these a few weeks back, and it was 17.8. Now this falls into the category of I've had to go and play with it and kind of, yeah, if you get the sweet spot. So basically the aim is to get the lowest accurate and proper value, and it just goes of moving it around, get the sweet spot, find it in the top, and I managed to get 15.7. So usually it's really easy to get like 17, but if you get the sweet spot you get 15.7, which is the best one I managed to get. Now, I know a lot of people are going to go, well, this is my, alright, bye. A lot of people are going to say, well, that's rubbish. Oh, that's absolutely rubbish, and I'm not interested in your project. It's stupid. It's a stupid concept. Go away, right? So look, we'll just wait a minute for those people to disappear. Right. So look, the reality here is now, this is an industrial panel, and it's a reasonably good latency done with the tester. And obviously, I would like it to be more, but to be honest, it kind of, I'm not the best gamer in the world, but I found that kind of, I don't even notice it. Personally, now that equates to just under 1/60th of a second. So That's great. Having said that, you'll notice there's another picture under here. Now remember I said about I do want to go and find a third panel. Now that third panel is going to have to compete with this one, which is my Philips. And it is a Philips 243V. So if you're thinking I want to get a flat screen panel that's that, a Philips 243V. It's crazy. Now, but don't get overly excited, because when it comes to the actual test, I actually incorporate this in the last one in the test. And you'll see, although it's got that amazing lag from that test, the reality is a little bit slightly different when you're going through the GBS control. It actually comes out slightly differently. So hold on for that, and then and just work our way through it. Right. So again, there's good news here and there's bad news. So but I'm going to step through it all. And this is coming out of the machines, and you can see it. And you make your choice of latency from this. If you think it's okay for you, great. If you think it's not, then the problem is obviously if the Kickstarter doesn't succeed, the platform won't exist, which means you won't be able to put that more powerful panel in it. But as I said, I am going to go and find a better, faster. The third panel, the second panel is my standard default one, which is this panel. The one before it is going to be, as I said, a lower cost version. And the third panel is going to be chasing that figure. So to get that kind of performance. Right. Now, basically this one is the standard component. So when you buy the panel, as completely standard, it comes with component input, 2 composite inputs, a composite out, HDMI in, VGA in. It'll be listed anyway. So that's the standard inputs. So as you can see on this, let's stop it here. Right, now can you see, basically the one on the right is 2 frames, 3 there, but what it does is it kind of, so I think it's about 2 1/4, but sometimes it actually drops. But the component is the audio visual stuff, so the it's about 2.5 frames, but it comes back in again. So it kind of overall it's 2 frames ahead, behind. Let's get that correct, shall we? So as you can see, it's a couple of frames behind. That's the component. Okay, so two. Now that's again 60 FPS. This is running at 60 FPS, as you can see. I'm going to go all the way up to 60, and then scroll around. There we go. So the component is probably just under, but averaging out 2 frames behind. Okay, which to be honest, I didn't think it was too bad. Right, that's component. Now that's the standard component. So let's get the really bad one out of the way. This is the composite. Okay, this is default composite. Now the one thing the composite does, which I will have another video somewhere showing the kind of quality with the composite. It's a lovely composite, and it stabilizes, does everything. But of course that comes at a bit of a cost. So let me run this one up. Pull that one across. Right, now you can see it's 3 frames behind. Okay. Now what I found is, we can see here, it actually pulls back again, but it's between 2 to 3 frames behind, and it's still 2. Let's see if I can find a. Trust me, it goes down to about 2.5, but it kind of, again, bear in mind this is composite. Remember, composite and component are going through the audio visual engine, which is different to the others. Okay. Oh yeah, I'm 3 behind again now. And then it pulls back. You see what I mean? It kind of pulls back again. So my reflex is, I don't notice it. I know some people want it better than that. Now that's composite, remember? So that's the composite. We've done that one now. Right, now this is where it starts to get interesting. Right, now this is when you've added in our GBS control system into the mix. The last two were the built-in component and composite. This is actually connected to VGA, so it kind of tells you what the VGA is going to be like. Okay, so this is VGA input, and what you'll see again, it's kind of 2 behind. In fact, sometimes it dips down a bit, gets a bit closer. Yeah. Yes, there you go. See, it kind of dips under, but it's it's a good average 2. Yeah. And if we just skip through. Oh, I think I'm at the end. There you go, 21, 20. So again, 2 frames behind. So again, that's the decision you make. Right, now the next one, just now in case you're thinking, well, prove it. Here's the same thing, but this time showing you the actual basic card. So here's the GBS. Now that little board on the right hand side here, that's in fact that's an old version. There's a new version with much more functionality on it, which is going to do CGA and EGA as well, so a bit more involved. But that's the GBS control, and you can see the SCART plug at the bottom. Again, we're 2 frames behind. So again, 2 frames behind. Yep, there we go. So that's 2 frames. So you can see that's the GBS card, and so it's the same one as the other. Right, now the last one I think was really interesting. Now, if you remember rightly, I showed you this. 1.4 milliseconds of lag, okay, from my Philips, which is phenomenal, right? Now the actual HDMI panel on here, or the input, is 15.7 millimeters. So milliseconds of lag. But let's do something interesting. Now what I did was I connected GBS control to my fast monitor. Now what you'll see it is 1 frame behind. Okay, so it is 1 frame behind. So the same GBS controller. So our system and panel is adding about 1 frame of latency to it. But if you skip through this, and I probably won't be able to find it. So can you see where was it? It was on there. It actually dips. There's a couple of points where it actually dips lower. Probably not going to be able to find it. But you can see it's basically it's one frame. Okay. Here, can you see that? 56, 58. So it's still not absolutely perfect. Okay. Now GBS control is absolutely brilliant, and really does make a difference. But hopefully you can see that by doing it this way, because what's coming out of that display is coming in real time. There's both the RGB out from the Amiga and the composite out are both identical, coming out at the same time, and they're just firing in different routes. So you can see the latency. I think hopefully that shows you the latency that you're going to get. So just to be clear, so you see we look on 2 frames on that really fast panel. So, and then you'll find it will pull back. Yeah, it's pulled back again now. So it kind of pulls back to 1. I would say if you say average it around 1.5 frames. And the GBS I think is around 2, so that there is a difference. Yeah, there is an absolute difference. But I think for the basic version, the display, I think the quality is really nice. And there is another video on this Kickstarter showing the quality of running a Dreamcast. Have a look at that. That's running in Composite, funnily enough. I'm going to do some tests with like for the Dreamcast, because I've got all the different input or outputs, should I say, for the Dreamcast. But unfortunately I can't do 2 together, so it's a bit tricky. But if you'll notice if there's any latency in Composite, you'll now know it's like 2 and maybe 2.5 frames it's dropping behind, but at least we know that now. Anyway, so hopefully that was interesting. Hopefully it's given you an insight. As I said, if the Kickstarter is a success, because remember this is a platform. This is about building these, okay, and get them on the market so that we can do different panels, we can do different setups, put a mister in it, etc, etc. But yeah, hopefully that was informative, and you can see that whilst it might not be the latency that you want, hopefully the third panel will blow people away. Okay, and if you don't want to buy it and you're waiting for that, well just buy that or just buy this panel here. It's Philips 243V. Buy that, just set it to the way you want it. It's a great panel, about £100. That's all you need. Anyway, thanks so much for that. Hope you support the Kickstarter. All the best. See you.